today we have the problem, what is the largest divisor of 342 that is also a factor of 285? How do we solve a problem like this? Today we are going to use what's called the Euclidean algorithm. Now what's the idea behind this? The Euclidean algorithm helps you find the greatest common divisor between two things. We want the largest divisor of 342 that is also a factor of 285. So in essence, we're looking for the greatest common divisor between the two. So this is a good algorithm to use. And the algorithm looks like this. The greatest common divisor of two numbers, a and b, equals the greatest common divisor of b and a minus b. Okay, great. But let's see if we can unpack what this means, really understand what's going on here. So 342 and 285. Let's say their greatest common divisor is some number, we'll call it d. 285, we'll call it d. We don't know what it is yet, but we know we're finding d. That's what we want to find. What does it mean? Well, we know it's a divisor of 342, so we know 342 equals some number k times d. For example, if d was 2, then k would be 171. It would be 171 times 2. Similarly, for 285, it's also a divisor. It also has d as a factor, so we can have d. And it's multiplied to something. We'll call it m. Great. But now, since they both share a d, we can do something interesting. kd minus md. What does this mean? We can factor out the d. We get k minus m equals d. And what does this equal? We know kd minus md is 342, because that's kd, minus 285, because that's md. And this is equal to 57. But look, 57 is k minus m, which is a number, times d, which is the greatest common divisor. So 57 also has the divisor. What this means is that the greatest common divisor of all three of these, 342, 285, and their difference 57, it's all d. Now, we don't like to have three of them. We rather have two, because that makes it easier to look at. We don't have to look at three of them. So we'll just get rid of the biggest one. Big numbers are annoying. It's little numbers, if we have like 6, that's really easy. It's 2 and 3, right? Or 1 and 6 as well. So we want to do smaller numbers. So now look, we have the greatest common divisor of 285 and 57. Our numbers got smaller. And if you notice, the smaller number from before, 285, is now our bigger number. And our new number 57 was the difference, which is exactly what it says here. So that's how I remember it. If we have GCD of 342 and 285, I think of it that the 285 slides over here to be the bigger number, and the new number is their difference. In fact, we can keep doing that. GCD, 57 slides over here. And here's where it gets a little bit different. 285 minus 57. That's 228. But 228 is bigger than 57. Well, we can subtract 57 again. And we're still doing the same thing. We're subtracting something with a factor of d in it. So we can always factor out the d. And it'll always have d as a divisor. So I can subtract as many times as I want. You could even go to negative numbers. You probably don't want to do that though. Okay, so we have 114, d7, d7, oh, now look, got 57. In other words, if you subtract enough times, you get GCD of 57 and 57. That's obviously 57. So that must be our answer.